Here is the video of the yield line analysis example. The slab, rectangular slab shown is 6 by 3 meters, and the reinforcement in longer direction has the moment of resistance MP, and in the shorter direction 1.4 MP, where MP is 10 kilonewtons meters per meter. The slab is simply supported along one shorter edge, fixed along two longer edges, and free on the fourth edge. The collapse load on this slab needs to be determined. The yield lines, positive or sagging yield lines, can be drawn from the intersection of the lines of supports and then parallel to the two fixed edges. So these are the sagging, positive yield lines. The negative yield lines are along the fixed edges. Now the external and internal work can be written, starting with internal work. On element 1 of this slab, the triangular element, the internal work by definition is the projection of the yield line onto the axis of rotation, which is 3 meters, times the moment of resistance of reinforcement for this element. The moment of resistance of the reinforcement along the longer edge is the one which should be taken, so MP, times the angle of rotation of element 1. Angle of rotation can be found as the maximum displacement of the element divided by the distance from the point which moves most to the supported edge. In this case, the length is not shown. Let's take it as 2 meters. This is assumed, obviously, to find the exact one. The correct procedure should be followed, but assuming that this length is 2 meters, the rotation is then delta divided by 2. Delta is the maximum displacement along these edges, and this then gives 3 times 10 times delta half, (15 delta). For element 2, internal work will be for the positive or sagging yield line, the projection length of projection is 6 meters. The moment of resistance is 1.4 MP, and the angle of rotation is delta divided by 1.5 meters. So this is 6 times 1.4 times 10 times delta over 1.5, 56 delta. For the negative yield lines, 56 delta. For the negative yield lines, the length of projection of the negative hogging yield line is 6 meters, so it's just the length of the support of the fixed edge, basically, times the moment of resistance of the holding reinforcement is 0.7 MP, and the angle of rotation is the same as for the positive lines, delta over 1.5, and that gives 28 delta. So both positive and negative lines need to be taken into account for element 2. For element 2 dash, which is the same as element 2, positive yield line work is also 56 delta, and negative yield line 28 delta. So the total internal work, when we add for all these elements, is going to be 15 plus 56 plus 28 times 2 delta. And that's going to be 84, 188, 198, 203 delta. No, I'm wrong. 84 times 2 is 168. 168 and 15 is 183 delta. 183 delta is the total internal work. Next, we can find the external work. For element 1, by definition, external work is equal to the area of the element, so it's 1/2 times 3 times 2 times the load times the displacement at the centroid. If the displacement at the tip of the triangle is delta, then the displacement in the centroid is delta third. And that is equal to W delta. For element 2, we have to take into account the whole element 2, so dividing it into a triangle and a rectangle. For a triangle, the area is 1/2 times 2 times 1.5, and the displacement in the centroid of that triangle is delta third. So taking into account this triangle, plus the area of the rectangle is 4 times 1.5, and the displacement in the centroid delta half times delta, and that's equal to 0.5 plus 3.5 W delta. For element 2 dash, it's also 3.5 W delta. So the total external work is equal to 1 plus 3.5 plus 3.5, 8 W delta. Setting internal work equals to external, 183 delta equals 8 W delta. Delta and delta can be cancelled, which means that W equals 183 divided by 8, which is 24 approximately kilonewton per meter square, which is the collapse load this slab can take.